In this video, we're starting our section on monomials. So our goals are to recognize what monomial and polynomial expressions are, and to add, subtract, multiply, and divide monomial and polynomial expressions. So in this video, we'll talk about what monomials are and get into how we multiply and divide them. So a monomial is a one-term algebraic expression that looks like I can have some number in front multiplying powers of variables that might be multiplied together. Like here, I just have x squared, or for the next term, next monomial, I have a 7 in front, multiplied by, I got multiple variables here, multiplied together. So, well, with this third one, I have a division going on, which doesn't really seem to show up in this definition, but I can rewrite this by putting the 3 to the front as a 1/3. Now that's the number in front, multiplying x times y squared. Okay. So in fact, with all of these, this is a one-term expression. This is a one-term expression. I have multiple variables here, but they're all multiplied together, so that's considered to be part of one term. And the negative in front is technically a -1. With the z over w, I can rewrite that as z and then bring the w up and make it w to the -1, because on the denominator it's a +1. Even with the square root, I can rewrite that as a variable to a power, because this becomes a negative in front, y to the 1/2 power. Okay. So in calculus, it's often helpful to rewrite monomials in what we call standard form. In standard form, we pull any constants to the front. Any sort of division you have with variables, you turn those into negative powers like we did here. And we rewrite roots using fractional powers. So for example, if I have this, I can move the 5 and the 2 that are getting multiplied to the front as a 5/2. And then y, cube root of y is y to the 1/3. And when you move it up to the numerator to get rid of the division, it becomes y to the -1/3. And now this has this standard form. The number in front multiplied by all the variables that are multiplied, 2 powers. So to multiply and divide monomials, we need to remember our exponent rules. So I want to give us a quick 30 seconds to see, can we fill out the blanks here? So pause it in 3, 2, 1, pause it, and try to fill out these blanks. Okay, so hopefully you did that. Let's fill them out now. So when I'm multiplying two terms like this with the same base, you add the exponents. So x to the a plus b. When you're dividing two terms like this with the same base, that x, you subtract exponents, x to the a minus b, and then with a power to a power, we multiply the exponents. So x to the a times b. All right, so let's do some problems. First, I want to rewrite these monomials in standard form. So in a, I'm multiplying these two things together. And I notice within the parentheses, I have like this multiplying this, and then I have this multiplying this. So overall, there's 4 things that are getting multiplied. And when I'm multiplying a bunch of things, it doesn't matter what order I do the multiplication in. So I can multiply the 5 and the 7 first, and then multiply the x terms together. Because 5 times 7, that's 35. And then for x squared times x to the 6, well, that's this addition rule. I'll get x to the 8, adding the powers together. And okay, that's my answer. Okay, I got the number in front times, and then my variable to a power. With b, well, okay, I got this fraction. I want to move the number to the front, which is that -4. And then I want to get rid of this division by a variable by moving the variable term up to the numerator, and that'll make the exponent a -2. And I got it. It's in standard form now. Okay, so let's up the difficulty a bit. Let's say I want to simplify the following monomial products and quotients. So products means things getting multiplied together. Quotients means things getting divided. And I have all of that in this example. So, okay, I got this fraction. So I got to simplify the top and simplify the bottom. On the top, well, all the terms here are kind of multiplied together. So I see a y and a y squared. Let's start with those. That becomes y to the 3rd. Right, because this y is y to the 1, and adding the 1 and the 2, I get y to the 3. With the square root, I can distribute it, because the things inside it are getting multiplied. So square root of 9 times square root of x. on the bottom, we have a bunch of terms in the parentheses multiplied together, and then that whole thing raised to a power, so I am allowed to distribute the power to each term. So that'll give me 2 squared, and then x to the third squared times y squared. In fact, I notice with x to the third squared, I'm going to have a power to a power. So in fact, let's just simplify that right now. I multiply those powers. That'll give me x to the sixth. That'll give me x to the sixth. And then times, there's still that z out there. Okay. So, okay, let's keep simplifying. So, okay, I got a square root of 9 on top. Let's just move that number to the front. I get 3. And then the square root of x, I can rewrite that as x to the 1/2. The first x is just x to the 1. So now I get to add those powers because they're multiplied together. So 1 plus 1/2, I have to get a common denominator. That'll give me x to the 3/2. X to the 3/2. And then I still get that y cubed. Okay, that's my numerator. Over my denominator, 2 squared is 4. I got x to the 6th, y squared over z. Okay, so I'm getting this. I'm just a couple steps away, and I want to simplify this actually in 2 ways to show us 2 different approaches to doing this. So I'm going to, because everything on the top is multiplied together, everything on the bottom is multiplied together, I'm able to pull these constant terms out to the front and have that multiply everything that comes after 3 over 4. And then for these x terms, that's my division. So I do the subtraction rule. I subtract their exponents. You'll get x to the, so I get a good common denominator. 6 becomes 12 over 2. So 3 over 2 minus 12 over 2, that's x to the negative 9 over 2. If I do the same thing for the y terms, I'll get y to the 3 minus 2 is 1, so y to the 1. And this is z to the 1 technically. I can move that up to the numerator by making it z to the negative 1. Okay, nice. And that, I have it in my standard form. Sometimes we like to rewrite this thing to get rid of negative exponents. This problem doesn't ask me to do it, but if I needed to, I could easily do that. So I'll keep the 3 on the top. And the x term, the z term will move to the bottom because they have negative exponents. The y to the 1 gets to stay on top because that's positive exponent. On the bottom, I'll have this 4. I'll have x to the positive 9/2, and then z to the positive 1, which is just z. Okay, so that's what it would be if I wanted to get rid of those negative exponents. Another way, though, I could have simplified this is trying to divide the top and the bottom by any common factors. So I notice, let me copy this down one more time so it's easier for me to write down what cancels. I notice that if I look at the y terms, I can divide both of them by y squared. So if I divide this by y squared, I'll be left with just y. If I divide this by y squared, I'll be left with 1. Okay, because I divide by the smaller of the 2 powers. If I do the same thing with the x terms, I could divide by x to the 3/2. So if I divide this by x to the 3/2, I'll be left with 1. If you divide x to the 6 by x to the 3/2, I have to get a common denominator to subtract them. 12 over 2 minus 3 over 2. That'll leave me with x to the 9/2. Okay, so if I do this simplifying, I'm left with, 3 times 1, which is 3, and then times a y on top. Over, on the bottom, I get 4x to the 9/2, and times z. Let me try that z better, times z. Oh, that's the same thing that we had here. Okay, so these are 2 different ways of going about it, and it's helpful to understand how both of them work. Okay, so part B. So what if I have this? So even though this is technically not a monomial on the top, I have 2 terms getting added together. This is what's called a polynomial term on top. I can still simplify this in the same sort of way. Because I noticed this whole thing on top, I could write that being to the first power. The square root on the bottom, I could write that as 2t plus 3 to the 1/2 power. And I have 2t plus 3 to the 1 divided by 2t plus 3 to the 1/2. Oh, so I get to do my subtraction rule. This becomes 2t plus 3 to the 1 minus 1/2. But 1 minus 1/2, that's just positive 1/2. Okay, so I could write my answer like this. Or I could rewrite that as that's a square root. Square root of 2t plus 3. Okay, now we got it. So in calculus, it's going to be very helpful to be able to quickly convert between algebraic expressions written in this way, and if I were to rewrite that square root of x as x to the 1/2 and bring it up to the top so that I get x to the negative 1/2, to be able to quickly go back and forth between the two.